Hello guys, happy to meet you. So I'm Robin from FIV. I'm going to speak about liquid hydrogen and how we support that in the mobility ecosystem. So just as a reminder, FIV, we are an engineering group, industrial engineering group, and we have about 200 years of history, and hydrogen is not new to us. We've been working on hydrogen projects for the past 40 years. We are 8,500 employees worldwide, providing engineering services, manufacturing capabilities, services, with roughly 2 billion of sales across the entire world. Our mission on the hydrogen space is really to be a world-class and the first independent provider of key process equipment. So our positioning is providing the key equipment that are driving the manufacturing and the production lines on the hydrogen ecosystem. And we are here to provide the equipment to produce, convert, liquefy, and transport the hydrogen. Basically, when you look at what FIV is doing, we have two pillars in our activity. First one is what we call the energy side. Our goal, be the leading independent provider of equipment for H2 industrial applications. And on that, you'll find three elements. Liquefying hydrogen, and I will speak about that right after. Combustion of hydrogen, we provide the burners that are used in industrial applications. And piping, we provide all the piping and the skids for electrolyzer or H2 plants. That's what we call the energy side. And then we have the mobility side. Our job provides state-of-the-art technological solutions for manufacturing and assembly lines. We do H2 tank testing lines for tank vehicles. We do laser welding solutions for electrolyzer, fuel cell, bipolar plates. And we provide automated and robotic systems to manufacture the electrolyzer, the fuel cells, and the tanks that are used in the mobility ecosystem. Hydrogen, as I was saying, for us has been a long journey, as we have 50 years of experience on the liquefaction side. FIV started in the 1980s with the Corre space base, where we provided the liquefaction equipment. It started very, very small, 1 ton per day. And now we are supporting our customers to develop large-scale liquefaction units. And we've been doing up to 15 to 30 tons per day of liquid hydrogen that is then used on the mobility side. You see that the path is really accelerating, and FIV is one of the key independent suppliers to be able to support this journey on the liquefaction side. Why liquid? Liquid is starting to be booming on a more larger scale because it has many, many advantages, as we can see. First, the level of purity. With liquid hydrogen, you guarantee a very high level of purity of your hydrogen that is required to be fueled in the tanks. You have a well-balanced mass density and energy versus the other types of hydrogen. It's a powerful fuel. So liquid hydrogen has some benefits versus gaseous or other types of hydrogen. And you gain more volume, you have an ease of speed, you ease and you speed the extraction of liquid hydrogen. So today what we see in the market as FIV is that we are starting to have a ready and competitive solution for both hydrogen supply chain and as an energy carrier. And FIV is supporting this journey and this transition toward liquid hydrogen. To do so, I'm going to stop on one of the products that we are developing, which is called cryogenic pumps. Cryogenic pumps, they are definitely required when you look at the full value chain. When you need to transfer liquid hydrogen from a storage A to a storage B, if you want to do that at speed, when you have a high demand, you need a pump. And FIV is developing and manufacturing these kind of pump that we call transfer pump. We also have some specific products that we call high pressure filling pumps that are mostly targeting filling hydrogen into a vehicle tank. Again, based on a liquid supply chain. So you see that when you look at this value chain, from the production to the liquefaction to the transport to the end on the distribution to vehicles, you will need efficient, high-performing technologies that will allow you to use this liquid hydrogen. At FIV, we are currently developing the two types of pumps required to do that: transfer pump and high-pressure pump. I'm just going to give you an example of two projects that we are currently supporting on the mobility side with these technologies. Example one, this is what we are doing for captive fleet. We are working with one of our key customers on developing pumps and using pumps that are used to fill hydrogen tanks for forklifts. The picture that you see, it's the pump on site, so it's a real pump, real project. It has been tested. And you see here the advantages of this solution. 2 minutes refueling with that kind of pump versus 15 minutes for an EV battery recharging system. So of course it's not huge at the scale of a forklift application, but when you think about the upscale of hydrogen and the need for efficient and high flow rate systems with a high demand, these solutions start to be interesting. And this is where you have the example number 2, what we do for heavy-duty vehicles. We are partnering with one of our customers called Cryogenics, a German company. And here, what we are developing is a pump for heavy-duty applications with a key objective to fuel a hydrogen tank in 10 minutes. So basically, what we are doing today with traditional gas, traditional fuel. Our pumps, how do they work? You have a liquid storage. Usually it's a high volume storage, 2 to 4 tons, depending on the refueling stations that you have. And you plug on that a pump. The pump is taking the liquid, pressuring it up to 350 bars if you have vehicles with 350 bar tanks, or up to 700 bar if you have vehicles with 700 bar tanks. And we deliver this liquid hydrogen at a high pressure and at the required flow rate to make sure that we can fuel the vehicle as before with traditional gas. These two projects are fully real, ongoing with key applications. And our objective is to cover the full range between these two applications. Why doing so? Because it will allow us to address all kinds of applications for the heavy duty. Trucks refueling, marine refueling, aviation refueling, if it's based on high pressure tanks, as well as storage tanks refueling to store gaseous hydrogen based on a liquid supply. The other application that we do not see here, because we are currently developing it, is what we call transfer pumps. The transfer pumps, they are here to transfer at a low pressure, very high flow rate of liquid hydrogen. Again, the idea is to be able to transfer this liquid from a storage A to a storage B before its end use. Transfer pumps, they will target very, very high flow rate, much bigger than what we seen on the two examples, at a limited pressure to be able to reach this flow rate. So that's what currently FIV is doing on mobility for mobility with liquid hydrogen and how we are supporting the industry. If you want to meet us and discover a bit more on all the applications that we have, from the liquefaction, the combustion, the piping, the mobility side, we welcome you. Stand A46. We have our entire team here to be able to present this different solution, and we'll be more than happy to welcome you. Thanks.